My 8th video on my module on making statistical graphs. In this video, we're going to focus on the pie graph. Okay, and so pie graphs, you've seen these before. Basically, we use these when we want to discuss what percentage of an overall something is. Okay, when I say something, we typically use this for categorical data. So we say categorical, typically data types. So we'd say, for example, if we were to collect data on blood types, we say the blood types of 25 people at the Health Systems Academy, or different data or classes here would be A, B, and O. They would have their own categories because it's categorical data. But we have the frequencies as well. When we make a pie graph, the thing we want to be concerned with here, like we said, are portraying percentages. So we need to remember, how do we calculate a percentage in the first place? Remember, a percentage is equal to the frequency divided by the total number of the data. In other words, we're basically saying, like for type A, the percentage here would be the frequency 4 divided by the total number of people here, which is 25 is our N. So we say 4/25, and actually I'm going to scoot this to the left here a little bit. We say 4/25, which is the same thing as 0.16, so 16%, okay? And we just do this for everybody here. We'd say, well, 5/25, 5/25 is a fifth, so that's 20%. 10/25, which is twice as much as 5/25, so this would be 40%, so 40%. And last but not least, we say the frequency here is 6 divided by the total number of people. This would be 24%. And so if we were to add all these up, just to mention, you get 1.00 or 100% of your stuff. But we want to we want to graph this on a pie graph, right? So here's what we're going to have to come to accept, and it's this: if type A represents 16% of the overall people we surveyed, then we should color in 16% of the circle. And so what we're going to need to do is this. I say, since there are 360 degrees in a circle, the frequency for each class must be converted into a proportional part of that circle. In other words, for the first part of the graph here, we need 16% of the total circle, so we're going to need 16% of the entire 360 degrees. So what we'll do is we'll take that f over n that we just found, and we'll essentially multiply it by 360. So in this instance, we'd say I would get let me remake this here. We say 0.16 for our first class times 360 degrees. And what this will do is it'll tell us 16% of 360 degrees. So we say 360, we say times 0.16 is 57.6 degrees. So we list this up here, we say 57.6 degrees. And then furthermore, we say 20%. Well, I need 20% of 360. So we say 0.20 times 360. That gives 72. So we say, well, then 72 degrees should go in this category if that's 20% of the overall 360. Twice that. Now, the only reason I say that is because 20% times 2 is 40%. So this will be twice the number of degrees here. We'd have 144 degrees. And then last but not least, we'd say we need 24%. So 0.24 of the entire 360 is 86.4 degrees. So we're going to make this graph. My suggestion is kind of like a Pareto graph. We should always do the big category first. So if I had a protractor, the very first thing I'd do is I'd make a line right here to represent the boundary for our first class, or our first category. Our first category I'm going to go with is AB. Now I say 144 degrees. Now I don't have a protractor on me, but I do know straight up is 90. I do know straight to the left is 180 here. So 144 degrees would be somewhere in here. And of course, if I had a protractor, I'd be using it. Oh, I almost drew an arrow there. So used to trig. But we'd say this right here, this represents a theta that is about 144 degrees. Okay, so now I don't need to label this. What I need to be doing is labeling the category. So this is type O. So I'm going to label this type O. So now at this point, what I would basically be doing is, if I had a protractor, I'd need to now go to my next biggest category, which happens to be type O. Oops, that wasn't type O. That's a typo, get it? But not type O. We say type AB. So now we need to do type O, which is 86.4 degrees. I might turn my paper sideways, and what I mean by that is this line that you see right here, I might turn it sideways so now that it's facing this way, and the line that is facing here, it'll be somewhere like over here. But so that I have this imaginary kind of space here to put my protractor over, this would be like my protractor here. And so, and I would measure off of this line now, I would measure 86.4 degrees, which would be somewhere like right here. Okay, I don't have the capability to do that in this case, but I can say that 90 degrees would be about right here. So 86.4 would be somewhere about right here. So we say 86, oops, let's do this. We say type O. It's about this 86.4. So now I'm going to do a 72 degree direction. We say, well, this would be like 90 with this right here. So 72 would be like, somewhere over here. I'm going to say type 72 degrees went with type B, and then we have type A. So you can see that type A, 4, 5, and 6 for frequencies for A, B, and O respectively. You say A, B, and O, and the way I've drawn it here, O should be a little bit bigger than B, and I apologize. But you get the idea here, being able to represent this. The important thing is going to be able to find out what percentage each category constitutes of the total amount first, and then find that percentage of 360 degrees to get your number of degrees for each category. So